Okay, guys, so set 28, we're going to talk about a couple of different things. First of all, we've learned to solve equations. We've learned some algebra. Let's use it for something. Can we do that, Allie? All right. So, people, we often say or ask a question, and if we understood what we were asking, life would be so much simpler. So, say for example, you got this cookie recipe. I'm going to make this nice and simple, and it calls for 4.5 cups of flour. Okay, but you just want to do a half recipe. You don't want to do the whole thing. So then someone will say, well, what's half of 4.5? Ooh, I heard it. 2 1/4. You can do it in your head, can't you? Okay. What if this was? What if instead of 4.5 though it was 9 2/3? Yes.
Would it be 3 1/5?
You're not too far off, but that's not exactly half of it. Okay. So let's think about what we said before. Let's go back to that 4.5 again. We want to know what is half of 4.5. That question right there, right? Okay. And what you have to realize is when you say that, okay, that is, hey Reagan, that is a question. Just like every equation. Thanks. Okay? So, I'm going to add a little bit here. I'm going to say what number. Okay? So, let me show you how this works. I told you guys before, equations are questions, right? We often read them and we'll say x plus 3 equals 10. But it really says what number plus 3 equals 10. It's always a question. So this is a question. We can write it as an equation. So instead of what number, I'm just going to put n. Because what number is a big, ugly variable. Doesn't work very well, does it? Could we use empty box instead of n?
Yes.
Yeah. Could we use x?
Yeah.
Y?
Yeah.
A?
Yep.
Yeah, lots of different things. I'm going to use n. What about for is? If it is something, what do you guys think? Have you heard this before? Yeah, equals. When we say it is something, we mean it's equal to it. It's the same thing. Okay? And then half. What about of? Of something. I'll give you a little secret. Of means times. It always means times. Is always means equals, and of always means time. When we want half of something or a third of something, we mean multiply. Okay? So I'm going to multiply. Now I'm not going to write 4.5 right here because multiplying mixed numbers is horrible, isn't it? Right? We decided that was really, really difficult. So we're just going to write 8, 9. We're going to put 9/2 right here. So there it is. What number is 1/2 times 9/2? Well, it's 9/4, which is, isn't that 2 1/4? Now you guys could see the answer to that one beforehand, couldn't you? Okay, you could tell what the answer was. But even if we made it more difficult, could you still do this? Yeah, you can still do it. Okay? So we're going to be looking at these phrases that we're going to turn into equations so that we can solve them. Okay? Okay? So, when you see this, you need to write the equation and then solve the equation. And that's the way you need to think of this. It's an equation. It's a question. Okay? So 3/4. What does of mean again? What? Times. Okay. And then times what number? What do you want to put for what number?
Variable.
Yeah, what variable?
X.
Okay. Did you say x or n?
X.
X. I'm going to put n because I have no imagination. So when it says what number, I put n. If it says what fraction, guess what? F. When it says what decimal? Yeah, you got it. Okay. Is. What does is mean? equals 69. 3/4 of what number is 69? Now you notice I didn't put a dot here for times. I didn't use parentheses. I didn't put an X, for heaven's sakes. That would be more variable, wouldn't it? Okay, but this still means multiply, doesn't it? Okay, now do you guys all know how to solve this? I see some nodding. Yeah?
Reciprocal.
Yeah. So we're going to multiply by the reciprocal. And that's the same as dividing, isn't it? So when we multiply right here, what do we get? Come on. What do we get? 12 over 12, which is 1. Okay, so 1 times n. And over here, let's see. That's over 1. Will 3 go into 69? Yeah, so 3 goes into 6 2 times, and 3 goes into 9 3 times. Okay. 4 times 23, that's kind of hard. What about 4 times 20? 80. 4 times 3? 80 plus 12? 92. Okay. Now let's see if that's a reasonable answer. Okay. You guys know what 3/4 of 100 is, don't you? What's 3/4 of $1? 3/4 of it. Okay, 75 cents. Okay. Well, if 3/4 of $1 of 100 is 75, could 3/4 of 92 be 69? Is that a reasonable result? It is. It's reasonable, isn't it? If you do this incorrectly, will your answer be reasonable? No, it's going to be obviously wrong. It's going to be like, no way, that's not happening. Okay? Okay, let's look at a different one. These all work the same way. You're basically just writing it as an equation, and then it's a one-step equation you can solve. Okay, so question, let's write an equation. What do you want to put for what fraction? Dead silence. What do you want to put for what fraction? Anybody think of maybe putting an F for what fraction? Kedrick? What would happen if you put an X or a Y or an M, something different? Would it matter really? No. Okay. What does that mean? Times 40. Do you want to put dot 40? Do you want to put X 40? Do you want to put parenthesis 40? How are you going to show 40 times F? Yeah? How about this? Now, I know it's out of order, but do we ever write F40? That's weird, isn't it? Where does the numerical coefficient always come? Now if you were to put 40 or F dot 40, this would still work, equals 24. But I think you guys are big boys and girls now, right? We're not in elementary. We're gonna write it algebraically. So can we solve this? What do we do?
Divide by 40.
Yeah, divide by 40. This gives us 1F, which is what we want, and then 24 over 40. What goes into 24 and into 40? 4 does. What else? 2 does. 8 does. Ooh, 8. 8 goes into 24. 3 times. 8 goes into 40. 5 times. So 3/5. A little more than half of 40 is 24. Is 3/5 a little more than half?
Yes.
A little more than half of 40 is 24. Is that reasonable? Cooper, reasonable? He's always right, so we must be right. Okay? That's reasonable. And if you wrote it this way, you'd still divide both sides by 40. These would still cancel. You'd still get 1F equals 3/5. Doesn't really matter. Okay? All right. Let me show you one more. Okay. Let's write an equation here. 2.5. Ready? Do we like mixed numbers?
No.
Not in equations, huh? Okay. Of, what does that mean?
Times.
Okay, so times 240. Don't use an X for times or a dot or anything. At least use parentheses, okay? Is. Okay. What number? N. Okay. Let's see, I think we can reduce. 2 goes into itself once. 2 goes into 2 once. 2 goes into 4 twice. And 2 goes into 0. Now this is kind of hard, but what's 5 times 100? 500. What's 5 times 20? 5 times 20? 100. And 500 plus 100 is?
600.
Okay. There's our number. 2.5 of 240 is what number?
Christian Swearingen, come to the office, please. Christian Swearingen.
2
Please come to the
240s and another half of 240 makes 600. Is that reasonable?
Yes.
Reasonable. Okay. All right, so then the next little bit that you guys are going to be working on today are these type of problems. Remember these evaluate problems? If x is a 2. We all know how to do this. We've been doing it for a while now, right? Okay, and I always expect to see that you replace every variable with a parenthesis, and that you put the 2 inside, and then you evaluate, right? Okay, that's what I expect to see. Now the problems I'm going to give you today are the same problem, but they look different. They look like this. They say if f of x equals x times the quantity x squared subtract 3x, find f of 2. That looks totally different, doesn't it? Very different. So this is called function notation. Function notation. And this function has a name. Its name is f. Okay? That's what we named it. We named it f. Okay? Sometimes we use g of x, sometimes we use h of x. You can name them whatever, but usually these are the letters we use. And here's what it wants you to do. It wants you to put a 2 where x is. That sound familiar? So f of 2 equals 2 times 2 squared subtract 3 times 2. So this doesn't say 2 times f. It's saying where the x is, put a 2 there. Does that sound familiar? Is that exactly the same thing as this? It is, isn't it? Okay. And so we're working it out, and we say, well, this would be 2 times 2 squared? 4 subtract 6. So f of 2 is 2 times, what's 4 subtract 6? Negative 2, and so f of 2 equals negative 4. This is what I expect to see on your paper, which is the exact same thing you've been doing before, but we're saying f of 2 equals this. And then here's the nice thing about it. When you get down to the bottom, okay, what number did we put in where x was? 2. And what came out? Okay, so your answer, it shows what went into the function, and it shows what came out of the function. It just shows both things. So it's just a different way of doing the same type of problem. And this is called function notation. We'll talk more about it this week. Okay? So those are the 2 new type of problems for you on set 28. Let's get going. Yeah, time to get it done in class today.